Okay, now we're going to go work another example problem. We're going to find where the g of x is increasing and decreasing, and do we have any relative extrema. This time I'm going to use relative extrema, since in the last example I used local extrema. So first of all, you need to recognize that g of x is the product of two functions that are continuous for all reals, and therefore it's continuous for all reals. G of x is also the product of two differentiable functions for all reals, and therefore it's differentiable for all reals. So, okay, so g prime of x is 2x e to the minus x squared e to the minus x. The greatest common factor is x, and oops, don't forget the e to the minus x like Mr. Isaac. 2 minus x. Okay, now, this function is a product of three functions that are continuous for all reals, therefore it's continuous for all reals. Exists for all reals. Okay, so g prime of x is 0. Okay, now first of all, you need to realize that e to the minus x is always positive for all x in R. So the only way that g prime can be 0 is if x is 0 or if 2 minus x is 0, which means x is 2. So the critical points, let's add this step this time, critical points of g of x are x equals 0 or x equals 2. Now, if I wanted to justify that, I'd say because g prime of 0 is 0 and g prime of 2 is 0. Now, I'm just going to do this because some of my students need to see this. It's never 0, so I never mark it. It's always positive. Now, I'm going to look at this. I'm going to be greedy and go back to algebra 1. I'm going to think of that as a function. Its zeros are 0 and 2. It's a parabola that opens downwards because the coefficient of the square term would be -1. So it's above these zeros opening downwards. It's vertex. And now g prime of x. Oh no, 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 come back, no, no. Okay, the product of a positive and negative. The product of two positives is positive, and the product of a positive and negative is negative. Okay, so g prime, not g prime, g is increasing on. I look at the sign chart for g prime of x. I look for where it's positive there. The interval from 0 to 2. Why? Because g prime of x is positive on the interval from 0 to 2. Okay, now let's do decreasing. Again, look at the sign chart, but this time I want to know where is the derivative negative, on what intervals, what open intervals? Well, minus infinity to 0, or 2 to infinity. Why? Because, now look, be consistent in your rhetoric and in your use of logic and justification. You started using inequality in the first one, so hey, let's use an inequality for the second one. That does mean g prime is negative. And then don't forget to repeat your intervals, because College Board does not like it when you say, oh, on these intervals or the interval. They don't like it. All right. Now, Mr. Isaac, I always forget how to use the first derivative test. Okay, I'm decreasing, I'm increasing relative min. Okay, so g of 0 equals 0 is a relative min. Why? Because g prime of nothing is nothing. Because remember, you must show it's a critical point. And you can't stop there. G prime changes signs from negative, I better spell it out, let me not get in bad habits, to positive at x equals 0. Now, the last sentence, I'm going to go, hey, g of 2. Well, if you think about it, 2 squared is 4. So this is 4e to the minus 2 is a relative maximum. Okay, why? Well, let's draw this here so you can see your peak. Why? Because it's a critical point, so I need to say that g prime of 2 is nothing, and g prime changes signs from positive to negative at x equals 2. Again, it's just practicing. Now, in the next example, I have a wicked example where we're going to use the combination of paper, pencil, and technology.